Okay, I will start screen sharing now. Okay, welcome everyone to today's first FTC Bootcamp hosted by Team Mecha Mantises 19862. We are so excited to share our knowledge about FTC and robotics in general. And we're so excited to be just teaching you guys for the next 2 days. So before we get to all the technical discussions, let's get to know each other. So in the chat, we would like you to type out your name, why you're interested in FTC robotics or just robotics in general, and a fun fact about yourself. So we'll give you a few minutes to do that. I'm seeing some answers in the chat. Very nice to meet all of you. I'll let some more answers come in before I move on to the next slide. Okay, now with that, I'm going to move on to the next slide. So here is the agenda for today's meeting. We will be starting with a quick introduction to what FTC is, followed by what the program includes. Then we will be talking about hardware to build your robot, CAD for designing your robot online, software to code your robot, outreach to connect with the community. Next, we will be going over the FTC 2021 game plan. And lastly, we will be answering your questions followed by a fun Kahoot. Also, please make sure to join the Google Classroom code. I will be putting the code in the chat real quick. There you go. That is the code. And this is just if you have any questions about the boot camp or anything robotics related, you can just ask it in the Google Classroom. But before we move on to the next slide, let's take a group picture. So if everyone wants, if you want to turn your videos on, that would be great. We're just going to take a quick picture. So
you guys could turn off your camera like after the picture.
Yeah, you guys can do that after the picture. 3, 2, 1. Okay. Does anyone else, Aria, do you want to try taking like a screenshot or something, just in case my picture didn't turn out that well?
Yeah, I did that.
Okay. Okay, one more picture. Okay, are you done taking the picture?
Yeah, we can move on now.
Okay, so I will present my screen. Okay, now I'm going to move on to the next slide.
Okay. So what is FIRST? FIRST is a nonprofit organization to inspire children in science and technology. The programs include FLO Junior, which uses Legos without a brick/brain. FLO is a program which uses Legos with software using a brick. FTC is the next level of FLO, which uses metal parts with screws with no more Legos. It still uses a brick, which uses line-based programming. FRC is the next level of FTC, which has a bigger playing field and more complexity. Next slide, please. FTC, or the First Tech Challenge, is a worldwide robotics challenge for young students grades 7 to 12, and their main goal is to advance the STEM education for students. In FTC, different skills are required, such as being able to think logically, creative thinking, problem solving, and the ability to work in a team. These are not the only skills needed, but these are the general skills. As you show more interest for an aspect of FTC, you will need to know how to work in that field. The different aspects of fields will be shown in the next slide.
The different aspects of FTC are hardware, CAD, software, and outreach. And we will be going more into depth into these categories throughout our slides and over the course of the bootcamp. Hardware. First is hardware, which is the hands-on building process of the robot using robotics parts. There are different brand parts that we use for a robot, and we will be getting into those later on in the slides. Moving on to CAD. CAD stands for computer-aided design. Before you build your robot, you need to plan how it'll look, what materials to use, the dimensions, etc. So CAD is a great way to plan your robot before building it. We'll be getting into the applications we use for CAD later on in the slides. Software. Lastly, software acts as the brain for the robot. Without the software in our robot, it wouldn't be able to do anything. Some examples of what software helps our robot to do is move forward, move sideways, spin a wheel, and many more. We'll be getting into what the software applications and languages we use. In FTC, outreach is a way of reaching out to the community and sharing our knowledge of robotics with the community. There are two types of outreach projects. One is to share FTC robotics knowledge, and another is fundraising for robotics parts. What our team is doing right now is considered an outreach project because we are sharing our FTC robotics knowledge with our community. Next slide, please.
So now we're going to be moving on to hardware. And hardware is nothing but different components a robot is made of. So in FTC, robots are required to do certain tasks. And to accomplish these tasks, the robot needs to have attachments that 1, help it move, 2, pick objects up, 3, deliver objects, and 4, any other component to perform an accessory mechanism, which we'll be getting into later in the presentation. So let's start off with making the robot move. This is called a drivetrain. The drivetrain consists of wheels which rotate by motors. There are different types of drivetrains teams could use, but the most common ones are 4-wheel drivetrains, 6-wheel drivetrains, and 8-wheel drivetrains. So since every robot component is built on the base of the robot or the drivetrain, it needs to be sturdy and reliable. And teams could also choose which wheels they want to use for their drivetrain. Right now, we're just going to be talking about 3. So the first one is traction wheels. These wheels have good grip, but they're not good in turning. The next one is omni wheels. The omni wheels can move sideways because like around the edges, they're like little rollers. So that's how they can move sideways. And it could also move forward. And lastly is the mechanism wheels. And these wheels can move in all directions. So like forward, backward, and even sideways. So that's a good thing about it. But teams need to be aware of the drifting. And if you guys don't know what drifting is, it's like Like, let's say you code your robot to go forward, but then like it like drifts a little bit, so like it goes to maybe in a 45-degree angle, something like that. Okay, so now that we have the foundation of the robot covered, we need a component to pick up a component which picks up objects. So this is called the intake. As said before, an intake is a mechanism to pick objects up. So since the challenge for FTC changes every season, there are a variety amount of like intake systems teams could build, and they're all really creative. But for last season, our task was to put boxes and balls, they're called freight, into a shipping hub. And for that, we built a wheel which spins the boxes and balls into a intake box. So yeah, that was our intake. And the third requirement is to deliver the picked up object. So this is called the outtake system. And a way to imagine this is that if your friend is writing you a letter and wants to ship it to your house, so what's the process? So first, the letter goes in a van. You can think of that as the intake, and the delivery man is delivering it to your house. That's the outtake. It's being delivered to you, right? And same like the intake system, there are many creative ways to build the outtake depending on the season's challenge. And finally, let's talk about the accessory mechanism. So in FTC, there are 2 missions a team is supposed to complete. The first one is the main mission, where you just use your intake and outtake system to complete. But for the second one, you need to create a separate attachment on the robot to complete the task. So for example, last season, we needed to spin a wheel, and we did that by building an attachment on the robot, which would do the task. So in conclusion, on the slide, we covered the different required components to do different missions. So next, we're going to be talking about gears. Gears are also an extremely important part of hardware. They allow us to transfer power along different axes, meaning that you could take the power from the motor and transfer it to another place. So you won't have to waste another motor, and instead you could do multiple actions. So gears allows to change speed, known as gearing up and gearing down. You could use these pictures as a reference. So gearing up means that you need to increase the speed of the second gear. This means that you take a larger gear, which has more teeth, and teeth mean like more spikes of the gear. So you take that and connect it to a smaller gear with less teeth or less spikes. If the larger gear is powered by a motor, the second gear would run faster. And this is also vice versa. If you start the gear with less teeth, less spikes, which is powered by a motor, and connect it to a gear with more teeth, the second gear power of the motor will move slower. So this is known as gearing down. This is useful if you need to change speeds for your different tasks without changing the power of the motor in your software. However, if you increase the speed coming from the motor using gears, your torque will go down, while if you decrease your speed of the motor, your torque will go up. So now I'll be going over sensors and motors. A sensor is defined as, it's like used to measure the condition of the robot and its surrounding environment. The distance sensor is used to determining the distance of an object from another object. It's kind of like self-explanatory. And yeah, the leftmost picture shows a visual representation of how the distance sensor looks like. And the gyro sensor can detect the angle of tilt for 1 second or the angle of rotation for 1 second. So I'll give you an example. One thing the gyro sensor can do is sense that if the robot is on the ground or not, flat against the ground. So yeah, you could see a picture of the gyro sensor. So this is actually a control hub, but the gyro sensor is like mounted inside. And the next sensor is the color sensor. The color sensor detects the color of a surface. This sensor will capture the color of an object and recognize what color it is. So like, that's kind of cool, right? Like if you point it to an object, it could sense what color it is. And lastly is the camera sensor. The camera sensor is used to see different things on the playing map. So the program used for this is TensorFlow, which is like a kind of program. And last season, our team used TensorFlow in the camera to detect where a duck was on a map. So we one of our tasks was to detect where a duck was on the map and move accordingly. Next, we'll be talking about the motors. A motor is a mechanism which helps the robot function. The most used motor in FTC is the DC motor. DC stands for direct current, and this is the motor used for rotating parts. The first thing that comes to mind, at least in my brain, when someone says rotating parts, are wheels, and this is exactly what DC motors are mainly used for. It's for making the wheels move, but it could also be for rotating different parts. So yeah, there's a picture of the DC motor on the screen. And the last is the servo motor. And this is the more precise, a smaller version of the DC motor. It basically does the same thing. But yeah, there's also a picture of the servo motor next to the DC one. Next slide, please.
So what you're being shown right now is an overview of how the robot is usually connected together. So you can see two controllers, which are used to control the robot during the teleop period, and which connect to the driver hub, which is connected to the control hub through Wi-Fi. The control hub is located on the robot, and it is what runs the commands that are given in the software and controls all of the various attachments on the robot. So as you can see, these are things like the motors and like the intake wheel and stuff like that. Next slide, please. CAD is the planning of how a robot would look like before we actually build it. CAD is an important tool, especially during the early stages of your robotics season, when you are figuring out how to modify or build your robot to use it to its maximum efficiency. CAD is also used to save money and to make sure you are only spending money on the parts you need for your robot. CAD allows you to create 2D or 3D figures of certain parts on your robot. This allows for a better understanding of your robot's parts, as well as other dimensions. Our team uses Onshape and Fusion 360 to design some of our robot's parts. Some other softwares that other teams use to design parts include Tinkercad, SolidWorks, and even drawing their own designs. On this slide is an example of what we made for CAD for last year's FTC season. You can see our base robot, intake system, outtake system, carousel arm, and finally the whole robot. When designing a CAD, many factors need to be taken into account. For example, the dimensions of the parts, whether the design is feasible, and the actual purpose of the CAD. When we made the design for our intake system, our team had to change the design because it wasn't able to function as in the way it was shown in the CAD. Instead of 2 channels, our team used 1, and we also cut the wheel so it would work more efficiently. It is okay to change the design of the part if it doesn't function properly. But as long as you have a CAD that mostly works, it will show others and your team that you put thought into your design and planned out your robot before building something that might not end up working. Next slide, please.
Finally, the software of the robot tells the robot what to do, whether it is to move forward, move back, lift its arm, etc. The programming language FTC teams use is Java. The IDE or Integrated Development Environment our team uses is Android Studio, but others include IntelliJ and more. The libraries teams use are provided by FTC, the FTC SDK. Lastly, the 2 types of programs our team created for last year's mission were the autonomous program and the manual program. In the autonomous program, the robot needs to do certain tasks by itself, so the code is written for the robot and didn't need to be controlled. However, for the manual program, the robot was controlled by team members, controlling where it went, how fast it went, and the sequence of things that it did. To test our code, our team used the FTC simulator, which has the same layout as a robotics competition, and a robot that would run the same the code inputted. The FTC simulator shows whether the code was given and was functioning properly. This helped us throughout our FTC season because it allowed us to try our code on a smaller scale robot before using it on the real FTC robot. This allowed us to fix any errors in our code and test our code as many times as we wanted to without the robot to be present. Next slide, please. This is the top layer structure of the software our team uses while programming our robot in FTC. I will give you an overall description of each of these parts and connections. As said in the previous slides, we have two types of programs we run on our robots, the autonomous and the manual programs. Both of these programs use the FTC SDK, the library FTC provides us, allowing us to use all the servos, motors, and sensors. The program also uses our own class called the Mantises class. This class helps with initialization routines, hardware mapping, and providing functions for the robot. If you don't know, the hardware map is what tells the software what motors/sensors are connected to which ports to the robot, so we can easily control those components. Lastly, the FTC SDK uses the robot hardware in order to run the tasks on the robot. Next slide, please. Our Mantises class makes the software more modular. Our Mantises class helps so that we won't have to keep on importing the DC motor and servo motors as a parameter each time we call our robot function. This way our code is clean, efficient, and avoids code repetitions. Next slide, please. Software libraries and software development kits are important because they help us code more efficiently. They allow us to use code that other people already made while understanding that code as well. This means we won't have to recode the complexity and add our own unique ideas. Some useful libraries and SDKs include the FTC SDK, which is the development kit that FTC provides, TensorFlow, which is an AI image detection library and helps us detect custom elements for the game. Roadrunner is an odometry library that helps with odometry precision and makes your robot move more precise using motor encoders. If you don't know, odometry is a library. It's like a type of software that basically makes your robot more efficient while moving so that in autonomous, you can be more precise. And Viforia is a development kit that allows us to get live feedback from our camera sensor. Next slide, please. These are some problems and solutions that teams encounter during their first year of FTC. We will go more in depth of these problems with their solutions in the following meetings. Next slide, please.
So this is the FTC game plan. So as you can see, there's a mat, and basically the FTC 2021 challenge was called Fright Frenzy. This was last year's. And the robot mission during this challenge was to get a certain number of elements onto the shipping hub or storage unit. So additionally, there were various numbers of ways to score points. So it was up to the team to decide whether what they would do to score the maximum number of points attainable. In the picture that is being presented, there's a blue side and a red side. So these represent the different alliances when the robots are competing. So essentially, there are 4 robots on the map. So there are 2 teams that make up each alliance, as said. And the first part of the game is called autonomous period. During this time, the team members will not be able to control the robot. So it's the robot moves based on the code. And next comes the manual period or the telia period. And this is where the controllers can control the robot and do whatever the team members want it to do. Next slide, please.
Okay, so now we'll stop sharing and Anitej will share a video of the 2021 FTC game plan.
So now I'll share a video of the FTC 2021 game plan. And it's basically to help get a better visualization of what Shreya said on slide 17.
A team consists of up to 2 driver operators, a coach, and a robot. The robot must be built from materials specified in the game manual and fit within an 18-inch sizing tool, but may expand after the match begins. Each match is played with 4 randomly selected teams, 2 per alliance. Your opponent for one match may be your partner for another. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. In the back of the field are taped-off warehouses, which are alliance neutral. Obstructing the warehouses are barriers that robots must drive over or around. At the front of the field are Alliance-specific storage units. Alliance-specific carousels are mounted on the front corners of the field walls. Alliance-specific barcode tape is located between the warehouses and the storage units. 4 unique navigation images are located around the field perimeter. 2 Alliance-specific shipping hubs and a 3rd shared shipping hub are positioned as shown. Outside of the field walls are the red and blue Alliance stations. There are 2 types of freight: 20 pieces of cargo, 2.7 inches in diameter, and 2-inch square boxes in various weights: 30 lightweight, 20 medium, and 10 heavy boxes. 4 of the lightweight boxes are marked with an X. In addition, rubber ducks will play a key role in the game, and teams will be constructing their own custom-designed shipping elements. Before each match, the freight is stored in the warehouses, and a preload box is placed onto the field for each robot. A duck is placed onto each carousel and in the middle position of each barcode. The remaining ducks are stored in the Alliance loading docks. Teams then place their robots on the field, touching the wall adjacent to their Alliance station, but not in a warehouse. The teams then place 1 preload box for each robot. A team may then decide to use their own shipping element in place of a duck on the barcode, or store their shipping element in the loading dock. The duck or shipping element on the barcode is then randomized to one of 3 locations. The players and field are now ready. Each match begins with a 30-second autonomous period. During this period, there are a number of ways for teams to score, using only pre-programmed instructions and sensor inputs. Delivering the duck from the carousel earns 10 points. Each piece of freight delivered to the Alliance's storage unit will earn 2 points. Each preloaded box placed on an Alliance's shipping hub earns 6 points. But there are ways to earn bonus points. If the box is placed on the correct level as indicated by the duck's location on the barcode, the Alliance earns a 10-point bonus. If a robot places its preload box on the level shown by its Alliance's shipping element position on the barcode, it will earn a 20-point bonus. A robot parked on its Alliance's storage unit earns 3 points. However, if the robot is parked completely in the storage unit, it will earn 6 points. A robot parked in the warehouse closest to its Alliance station earns 5 points. If the robot is completely inside the warehouse, it will earn 10 points. Following the autonomous period is the 2-minute driver-controlled period. During this time, Alliances scored points by delivering freight to storage units and shipping hubs. For example, each piece of freight delivered to an Alliance's storage unit will earn 1 point. Freight scored on an Alliance's shipping hub will earn 2 points on a level 1, 4 points on a level 2, and 6 points on level 3. Each freight scored on the Alliance's side of the shared shipping hub will score 4 points for their Alliance. The last 30 seconds of the driver control period is the end game. Robots may continue scoring freight, and there are also ways to earn bonus points. Delivering a duck or shipping element to the floor earns the Alliance 6 points. A balanced shipping hub at the end of the match earns 10 points. If an Alliance's section of the shared shipping hub is in contact with the tile floor, that Alliance earns 20 points. Robots parked in a warehouse earn 3 points. However, if the robot is parked completely in the warehouse, it earns 6 points. Each team's shipping element.
Okay, so that was just the game plan for the 2021 mission. So I will move on to the outreach. Okay, so outreach is a way to connect with our community by sharing our FTC robotics knowledge. And we have already went over how this bootcamp that we are conducting right now is an outreach program. Some of our past outreach projects include helping an FLL team, fundraising for our robotics parts, the Crayon project, helping redesign a website, collaborating with the mentor team, and making our own website. These are just some examples of what you can consider when considering an outreach project. All of these projects were either ways that we reached out to the community or fundraised for our team. By helping an FLL team, the Crayon project, getting mentored, and redesigning the website and making our own website, we either shared our knowledge in FTC or gained some knowledge about FTC. And by holding a fundraiser, we were able to raise money for our FTC robotics parts. Here are some pictures we took along the way. This first picture in the top left corner is us with the Crayon project team. And right below is the flyer that they wanted us to distribute to help save the earth by recycling crayons. This picture right next to the picture with the Crayon project is us mentoring a FLL team and showing them our FTC robot. This picture down below is us competing with our mentor team and just getting some advice about competitions. And this purple picture over here is our fundraiser that we were able to raise money for FTC parts. This picture in the corner is us showing the Crayon project, a demo of our FTC robot. And this picture in the corner is the website that we helped redesign. So before we go on to the Kahoot, does anyone have any questions? You can ask them in the chat or unmute. Okay. Looks like no one has a question. Okay, so now we're going to be moving on to our homework for today's lesson. So our homework is to create a Onshape account, and this is the link. I will put it in the chat. Or can someone put it in the chat? But yeah, that is the link for Onshape. And if you just do a quick Google search on how to make an account, it should be there. And I think this is the direct link that takes you to the Onshape process of how to make your own account. So now I won't keep anyone waiting. We're going to start the Kahoot now.
I'm going to paste the link in the chat and everybody can join.
Oh, Arian, I already pasted the link.
Okay, thanks. No, I meant the link for the Kahoot.
People can see the code on the screen.
Also, everyone knows how to play Kahoot, right? If you don't, you can just ask. Okay.
Okay, so we have everyone here, or is anybody missing? I'll give you guys.
I'll explain how Kahoot works while everyone is joining. So basically, there's gonna be a question on the screen, and on your screen, there's just gonna be like diamond, square, circle, and like triangle. But then you need to look at the Zoom screen because that's where it shows like all the question answers, and then you just pick whichever one you feel is right. And then yeah, after everyone picks, it'll tell you if you're right, wrong. The goal is to get as many questions possible if you can, right? And yeah, that's basically it.
Okay, so I'm gonna begin the Kahoot. It's gonna be unlocked, so anybody can join midway through. What are the 4 components of FTC? Okay, so it's outreach, hardware, CAD, and software. So all of these have to be used when you're participating in FTC. The other options are like computer amazing design, which is not the definition of CAD. Fun, although it's part of core values, it's not one of the 4 major parts. Okay. What does CAD stand for? Okay, so CAD stands for computer aided design. Computer app development is a completely separate thing. So okay, let's continue. Software means building the robot. So software is actually, let me let Aryav explain.
So software is actually, as I explained in the slides, it's like the brain, it's the brain of the robot. It tells the robot what to do. Building the robot is more like the hardware, and like the CAD is like shown before, like that's all a part of building the robot, but software is like more of the action, like telling the robot what to do and stuff.
Okay. Let's continue. What is a drivetrain? Okay, so the drivetrain is the base of a robot, not a rocket ship. So it's used to move the robot around. And then we have other parts like intake, accessories, and outtake. So it's the base of the robot. Okay. Multiple select. What is outreach in FTC? So you click multiple answers. You don't have to just click one. Okay, so sharing your knowledge about FTC is spreading growth about first. So that's outreach. And mentoring teams is where you're again sharing your knowledge about FTC, promoting STEM. Stretching your hands out would not really be considered outreach. Interesting. What are some examples of outreach? So this is only one. don't have to you can't select multiple answers. Okay, so talking with your friends would not actually be considered outreach, because if you're not talking about robotics or spreading knowledge about STEM, it would not be considered outreach. But raising funds for your team's robotics project parts is considered outreach. Okay, let's continue. Okay, so it's not first tech competition. It's actually first tech challenge. Just a little difference. But yeah. Wow, a lot of change in the leaderboard. Let's continue. What is an intake system? Okay, so intake system, Shreya, would you like to explain this?
Yeah, so an intake system is taking in an object. A mechanism, so for someone who said blue, it's not unable to take an object. It's an intake system to take in an object to pick up like freight or like whatever.
What is an outtake system? Okay, so
Yeah, good job. Most of you guys got it right. It's the opposite of an intake system. It's an outtake system is to deliver objects. So yeah, good job.
what coding language do we use in FTC? Python, Java, C++, or French? So we use Java. C++ might seem like an option here, but Java is the language we use. It's the language FTC uses. Why is it important to use CAD? Okay, so Neil, do you want to explain this?
So it is important to use CAD. As you can see, most of you got like it. It's important to use it to plan your robot. So it's not necessarily to see if others like the design, but it can also be used for that. But mainly it's to plan your robot and to make sure you're not wasting money on components you don't need. So red is the answer.
What are some libraries we use in FTC? Is it FTC SDK, FTC SRK, FTC SDK, or FTC Pro SDK? Okay, so it's FTC SDK. If Arya, if you want to explain this, you can go ahead.
Yeah, it's actually FTC SDK, not FTC SRK, because As I explained in the library slide, SDK stands for Software Development Kit, and SRK doesn't really stand for anything else, so it has to be FTC SDK. And it's not FRC SDK, even though no one answered that because we're doing FTC, not FRC.
Good job. Very close. True or false? Do we use Android Studio as an IDE? Okay, so we actually do use Android Studio as our IDE. There are other IDEs such as IntelliJ, PyCharm, but our team specifically uses Android Studio, as most teams. Okay. There. Okay, so we did do the crayon project, held a fundraiser for our team and to get robotics parts. And we also made the website for JCNC. So these are some outreaches you could do. We did not mentor an FRC team because FRC is not not FTC. It's a bit more advanced, so we didn't mentor them.
Yeah, we mentored an FLL team, but not an FRC team.
A lot of movement. How can you test your code without actually using a robot? Okay, that was a quick question. We do not use Android Studio. Android Studios is the IDE, but that's not actually what we use. We use the FTC simulator always to test a role. Okay. Okay, so it's false because CAD is used to build the robot before CAD is used to prepare or plan building the robot before you actually build it. Software is used to code the robot. Okay. We have a new leader. Final question. What does IDE stand for? Okay, so it's integrated development environment. Integrated development environmental is not actually what IDE stands for. So yes, let's see who won. In third place, Arya, 14,845, and we Aditya, and then the number one is Arya. Good job, everyone. And runners up is Dave and Rishabh.
Okay, so that was our Kahoot. I hope you guys had fun. And now it's time for the questions and answers. So if you guys have any questions, just let us know right now. You could also type in the chat.
Okay, so someone asked in the chat, how long does it take to build your robots? Does anyone want to answer that?
Yeah, I can answer that. So basically, it takes a while to build our robots because, as we said, we first normally CAD our robots so that we don't like waste money on like getting parts we don't need for our robot. And then first we have to CAD it, then we have to wait for parts to come. So it basically takes the entire season to build the robot since we're still like making it, we're still like improving it, etc. So it takes around the entire season. So the entire season is about a few months, 2 to 3 months from like, so the season's announced in the beginning of September and the first tournaments are around the end of November. So like around 2 months. Yeah, and about signing up for Onshape, you would want to create an education account because you have like more like you can do more things with an education account. So the link that we sent in chat would be for the education. So try to make an education account if you can.
Okay, does anyone have any more questions?
When I go to like sign up, it asks for like the school name and the website URL.
Yeah, you can put those in. Yeah.
Oh, what do I enter?
Just
Oh,
enter
you
like
can enter.
You
Oh,
just
you're-
enter your like school's name and like all the stuff that it asks for, so you can go to your school website and most of the information should be there.
This is so that Onshape, they give Onshape to you for free as a student.
Also the Google Classroom code is in the chat in case anyone missed it. That's where we'd be putting like all our updates, and you guys can also ask any questions if you have any like trouble like signing into Onshape or anything.
And just a reminder, there's like a bootcamp at the same time, 4 p.m. PST tomorrow and the following day on Wednesday and Thursday. We'll be going over like more detail into like hardware and software in those 2 days.
Okay, I guess if anyone doesn't have any more questions, then that's it for day one. Remember to sign into Google Classroom and then also sign into Onshape. And yeah, see you guys next class tomorrow. And thank you for coming.
Bye.